Alright, so in this video I'm only going to address the odd number of problems. I want you to complete all 10 problems, but I'm hoping that after going through at least 5 of them you have some ideas of how to complete the other 5 problems successfully. The one thing about multiplication and division that I mentioned last week is that basically this is like doing simplifying fractions supersized, as in you're doing a lot more factoring, a lot more simplifying, because with multiplication and division you don't have to worry about common denominators. So we're looking at this one big fraction. So the numerator, the x squared plus 5x plus 6 can be factored, and the denominator of x squared minus 4x can also be factored. So I would like you to factor those two expressions, and then decide from that two things. Number one, what would be the restrictions on the domain? And number two, I'd like you to simplify the fraction to the final answer, and then turn the video back on and ready to continue. So hopefully you've thought about the idea that in the denominator is an x plus 2, that hopefully there's an x plus 2 in the numerator. And there actually is an x plus 2 plus also an x plus 3, make the x squared plus 5x plus 6. For the x squared minus 4x, there just is a factor of x, and what's left is x minus 4. So for the restrictions on the domain, for number 1, x cannot equal 0. That would be for the first x. For the first parenthesis, x cannot equal 4. And for the second parenthesis, x cannot equal -2. This is where basically there are going to be 3 holes in the graph, or 3 places where x will never work because you have division by 0. Now for simplifying, x plus 2 over x plus 2 is 1. X divided by x is 1. And what's left, which is the 4, the x plus 3, and the x minus 4, those 3 things will always have, or almost always have, different answers. And there obviously will be a case where maybe x plus 3 and x minus 4 might be the same number, but in general they're going to be different. All right, so problem number 3. We're going to follow the same steps. So I like to take a look at the problems and decide based on the problem how can each thing be factored. Write the restrictions on the domain, and then try to simplify from there. When you're ready to check your work or to get some additional information, turn the video back on. All right, so for the first factor, first factor, x squared minus 16, it breaks down into 2 factors. It's a conjugate, so it's x minus 4, x plus 4. And then for the second one of x squared minus 3x minus 18, that would break down to x minus 6 and x plus 3. In the denominator, the x minus 4 squared, which would be 2x minus 4s. And then for the last one, x squared minus 2x minus 24, the 2 factors would be 6 and 4. 6 is negative and 4 is positive. So I'm looking at trying to pick ones. So x minus 4 divided by x minus 4 is 1. X plus 4 divided by x plus 4 is 1. X minus 6 divided by x minus 6 is 1. And what we're left with is x plus 3 over x minus 4. Now one thing I didn't write down was our restriction on the domain. So for the first one, x cannot be equal to 4. And that's also true for the second one. For the third one, x cannot equal 6. For the last one, x cannot equal -4. We have 3 restrictions on the domain. Final answer is x plus 3 over x minus 4. Moving on to problem 5. Go ahead and factor the quadratics. Make sure you write down the restriction on the domain. Identify the factors that will make 1, and then simplify it and down to the final answer. Turn the video back on when you're ready to continue. All right, so for this problem here, we have 4 quadratics, so 8 factors altogether. Definitely going to have some repeats. So we have x minus 3x plus 2 for x squared minus x minus 6. The second one, x plus 4 and x plus 2, that would give me the x squared plus 6x plus 8. The bottom left, the x minus 5, x plus 4, would give me the x squared minus 1x minus 20. And the last one is x minus 3x plus 2. Restrictions on the domain. I'm going to do that before I simplify. So for the first parenthesis, 5. Second parenthesis, -1. The third is 3. And the last one's -2. So this one has 4 asymptotes when we graph it, but 4 restrictions on the domain. For our zeros, for our ones, x plus 2 divided by x plus 2 is a 1. X plus 4 divided by x plus 4 is a 1. X minus 3 divided by x minus 3 is a 1. So what we're left with is x plus 2 over x minus 5. Problem number 7. Go ahead and again, same steps. Go ahead and set the problem up. Please keep in mind this is a division problem. This will change things a little bit. Go ahead and set the problem up. Factor it. Write the restrictions. Simplify it. Come back to the video as you need additional information or to check your work. All right. So for the second fraction, because we have division, we're going to turn this into multiplication. And in doing so, that means the numerator goes down to the denominator, and the denominator goes back up to the numerator. So basically, the reciprocal of the second fraction. We're looking to factor this. The second denominator is going to be factored. We do have a common factor for the first one. The others are quadratic, so we're looking for 2 additional factors for each of those. So I take the 5 out of the 15, I'm left with a 3. And if I take the 5 out of that, I'm left with a 1. Now, because the x is negative, I'm going to turn this factor I'm removing out as a -5, or at least a -1 times 5, because what I want to make sure is that I have it as an x minus something. So if I remove a -5, that makes this a 3. That makes this becomes basically an addition problem now. We're removing a negative sign out of that. So what we're going to end up with here is x minus 3. And then in the denominator, x minus 3, x plus 2. And the top, we have x plus 4 and x plus 2. So hopefully you see the advantage of taking that negative out, changing the sign on the 15 to make it a -3, and making that negative x become a positive x. So our restrictions on our domain is x cannot equal 3 for the first one, -2 for the second, and 0 for the last one. In terms of factors, we have an x minus 3 over x minus 3. That's why I'm taking out that factor of -5. So important. The reason why I did -1 times 5 is because I saw a 5 divided by 5 problem. So that leaves me with that -1 factor. And I see an x plus 2 over x plus 2. So I end up with a -1 times the quantity of x plus 4 all over x. You can probably see this written as x plus 4 over x with a negative sign out in front, just to indicate that we're going to end up with the opposite of whatever x plus 4 over x is. And then the last one, from 9, I see some definitely some quadratics, definitely at least potentially one conjugate. So again, complete the problem and then turn the video back on if you need additional information or to check your answer. All right, so the first one, well, we talked about this a little bit last week. So I'm looking for a factor of 2 and 1, and I want to get a 3 and 1 for the first and last numbers. I want to get a 5 in the middle. So the way I'm going to do that is I'm going to multiply the 2 and the 3 to get 6, and the 1 and the 1 to get to a 1. 6 minus 1, or actually negative 6 minus, plus 1 is going to be negative 5. So I want to make sure that the 6 is negative, and I want to make sure the 1 is positive. So I'm going to multiply the 2, and the 2 gets multiplied at the outside to the 3, and I want it to be negative, so make the 3 negative. So 2x times negative 3 is negative 6. And then on the inside, I want to make this a positive 1, so it's going to be 1x. So it's going to be 1 times 1x, which is 1x. So that gives me, that's a negative 6x here, and that gives me a 1x here, and that gives me that negative 5x in the middle. And you can use a diamond rectangle approach as well. The second one, the numerator is 3x plus 1 and 3x minus 1. Actually, it's a conjugate. These are all perfect squares here. No middle term. For the bottom again, I'm looking at 3, 1 and 3, 1, and I want to get a 10. So I'm going to multiply the 3's together and the 1's together and make sure that they're both negatives. So when I have the 3x, it's going to get multiplied to the 3, and I'll make sure it's negative. And then the 1x will get multiplied to the 1, that's the two 1's. And I'll make sure it's also a negative. So I end up with, this is my negative 10x here, so 3x minus 1x minus 3. And the last one, I noticed that the 4x squared and the 1, those are perfect squares, and I do have a middle term this time. This actually ends up being a perfect square. So it's the same factors instead of a difference of squares where you have a pair of conjugates. All right, so for our zeros, so if I let 3x minus 1 equals 0, add 1, and divide by 3, 1 value doesn't work is 1/3. X minus 3 equals 0, so that means x cannot be 3. 2x plus 1 equals 0, subtract 1, divide by 2, and that factor is repeated. So the 3 values that don't work here, x cannot equal 1/3, 3, and negative 1/2. Those are our restrictions on the domain. Again, let those things equal 0. The factors in the denominator equal 0. And in doing so, instead of equal to 0 and then solve for x, we can figure out what values will not be allowed. All right, so removing the common factors, make that a value of 1. Is x divided by 3 divided by x minus 3 divided by itself. Doing 3x minus 1 divided by itself. We have a 2x plus 1 divided by itself. So we end up with this 3x plus 1 over 2x plus 1. With, again, the restrictions being a negative 1/2, a 3, and a 1/3. Hopefully that was helpful in terms of an introduction to the multiplication and division. There was only one division problem we had to deal with for the first 5, but you may find that for 2 through 10 even, you have additional division problems. I believe that the handout that's given to the students who are absent, if you look at the last page, I believe the answer key is provided. But if it's not, we will address the answers on Wednesday.